Hello, my wonderful viewers. Welcome once again to Frequency Online Maths. So today we are going to treat this topic: homogeneous linear equation of what second order. So we are going to give introduction to the topic. Then in our subsequent videos, we'll be solving problems on it. Now, what is homogeneous? From the word homogeneous, something that looks what alike. Now, equation is when you equate something to any distinct variable or number. Second order, in differentiation, we have first order, which is in the form the y over the x. Second order, which is in the form the squared y all over the x squared, and the third order. So we are going to talk about the second order homogeneous linear equation of what second order. So this comes in the form p of what x, then y prime prime. This prime prime means what second order plus, thus they use p q and what r. P q of what x y prime plus r x y is equals to g of what x. Now we have conditions when this g of x, that's g of x, when g of x is equals to 0, we know that is what homogeneous. So when this g of x is not equal to 0, we know that is what non-homogeneous. So non-homogeneous. So if it is not equal to 0, we know that is what non-homogeneous. Now under this homogeneous, the general solution is known as the what the complementary what function. You understand? The general solution is known as the complementary function. So we are going to, if this p q and r, if p q and r are constant what functions, if they are constant functions, we are going to have what, if they are constant function, we are going to replace this with a. So we are going to have a y prime prime plus this one with b y prime, this one with c plus c y is equals to what 0. So we are solving for what homogeneous linear equation. So if it is equals to 0, it is what homogeneous. Now this equation, the typical solution to this equation is, I hope you can see it from there. So a typical solution to this equation of this equation is in the form a typical solution of this equation, that's this equation, we replace p q r with the following constants a, b and what c. So typical solution of this equation is in the form y is equals to exponential rx. Now if you differentiate, that's y prime, that's the first derivative, we give us, if you differentiate this, we are going to have r exponential rx. Now the second derivative will give us, this time this will give us r squared exponential rx. So we can place it here, anywhere we see this we can replace it with this. So we have a times r, this thing is what r squared exponential rx, then plus b, y prime is what r exponential rx, then c plus c, our y is what exponential rx is equals to 0. So it's equals to 0. Now, what is common here? Exponential r of x. We can factor it out. So we have ar squared plus br plus c is equals to 0. So we can divide through by exponential rx, exponential rx. So this cancel this. We have ar squared plus br plus c is equals to 0. So let me move over to this side. So with this, we have ar squared plus br plus c is equals to 0. So we can solve this thing quadratically or we can factorize, but in this homogeneous linear equation, it is more better to solve using almighty formula because it is not all the this thing quadratic equation that are factorizable. So we need to use almighty formula to solve it. Now this is equals to 0. So using almighty almighty formula, so r is equals to minus b plus or minus square root of b squared minus 4ac all over 2a. You understand? So when we have three cases, when we want to use this homogeneous equation, we have three cases because all our auxiliary functions, this thing are what? Auxiliary function, because we brought it down to what? Auxiliary function that we use to solve this. So when we have this our auxiliary function, when we want to find the almighty formula, when we want to solve this quadratically using almighty formula. So the case one is three cases. The first case is when the discriminant b squared minus 4ac, can you see it from there? Minus 4ac is, okay, let me write it here. When b squared minus b squared minus 4ac is greater than 0, the roots are real and distinct. Distinct means unequal. So the roots are real and distinct. If you remember in our quadratic equation, these are still the same thing. This is the discriminant. When b squared minus 4ac is greater than 0, the roots are real and distinct. If it is equals to 0, the roots are real and equal. If it is less than 0, that means we are getting imaginary words number. So, or complex number. So this is still the same thing. So this is case 1. Case 1. Now case 2. Okay, now the our general solution for this case 1 will now be y is equals to c1 exponential rx plus c2 exponential rx. So this one will be r1 and r2. So this is our general solution. So some people will say a exponential r1x plus b exponential r2x. They are still the same thing. This c1 and this c2 is important for finding initial value problem and boundary what value problem. Then there are sometimes they will ask you to find your c1 and what your c2. So this a simply represents all these things. So the case two, when the discriminant is the discriminant b squared minus 4ac is equals to 0, the roots are real and equal. The roots are what? Real and what? Equal. So we are going to have, if the roots are real and equal, so our general solution y is equals to c1 exponential rx. You are not going to put r1 in at this time plus C2x exponential Rx. So this is our general solution. I hope you can see it from there. So this is our general solution. So let me clean this side. So this is our general solution for case 2. So sorry for the interruption. So the third case, that's third case, case 3, when the discriminant b squared minus 4ac is less than 0. If it is less than 0, the roots are complex, are imaginary. So we have the general solution will be, first of all, let us write what our R1 will be. Our R1 is equals to, remember in complex, we have A plus B I, you understand? So this one is the real part, but this one is the imaginary part. So I will replace this B with alpha plus, let me say, beta what? I. Now our R2 will now be alpha plus beta I. So this one will be minus, sorry. So it will be minus. Now the general solution y is equals to exponential. Our alpha will now be what? Our r will now be what? Alpha x, then bracket c1 exponential. Our this thing c1 and this thing, sorry, cos c1 cos. Our x will now be beta x, then plus c2 sine beta x, sine beta what? X. I hope you can see it from there. So this is the what? General solution. And this general solution is known as what? The complementary function. By the time we'll be solving questions on it. First of all, we are going to solve questions majorly on this homogeneous equation. We're going to solve questions. After solving question on it, then we enter non-homogeneous equation. Then that non-homogeneous equation is when we have when the equation is not equal to 0, is equal to a variable. You understand? It can be x, which is algebra, or any variable. It can be 3, any variable. So we are going to do what? Equate it. We are if this thing is equated to a variable, so we are going to first of all find for this thing, the y. We are going to find for the complementary function cf, then we add it with the particular integral. Particular integral is when we are going to state the solution, you understand, when it is y is equals to c, y is equals to cx plus d, something like that. So we are going to introduce that one still. So but just learn this one. Wait for our subsequent videos on this. We are going to solve many examples on it. Thank you for watching, and may God bless you. Don't forget to follow us on our YouTube channel. Subscribe on our Facebook page. I noticed that most of you are not engaging on my page. Try and engage on my page. Write reviews. Follow our Facebook page. It is very interesting. Mass is fun. Bye bye.